Welcome to exercise 1B, like terms. You would have done a little bit of work on like terms in year 8. But if we have a look at the definition of like terms as a bit of a reminder here, they contain the same pronumerals, with each pronumeral having the same index. Okay, the pronumeral meaning they have the same letter or symbol. The same index meaning that they're raised to the same power. The rule that we need to always follow is that we can add and subtract like terms. If they're like, and we can add and subtract them. Unlike terms cannot be added or subtracted to form a single term. So we can't calculate them if they're unlike. Let's have a look at the examples. Which of the following are pairs of like terms? 3x and 2x. Do they have the same pronumeral? Yes. Do they have the same index? Yes, they do. The 3 and the 2 are the coefficients, meaning there's 3 x's here and there's 2 times x's here. But they are like terms. This example, B, 3m and 2n, we're looking that they have the same pronumeral. We have a pronumeral of m and a pronumeral of n. They are unlike terms. They don't meet the criteria. Notice our next one here, a little bit trickier. We have 3x's, x squared, and 3 times x. Now they might have the same pronumeral, the letter there, but the index is different. This one has an index of 1 and this one has an index of 2. Therefore, they are unlike terms. Let's look closely. Remember, we're not too worried about the coefficient at the front at the moment. We're looking for the same pronumeral and the same index. All right, with multiplication, because this is 2 times x squared times y, the order that they're in doesn't matter. We just like the coefficient to be at the front. So this one has an x squared. This one also has an x squared. Same pronumeral, same index. This has a y, and this also has 1y. So therefore they are like terms. Here's another example where we have, if we look here, m times n and n times n. So this is saying that this is 2 times m times n. That's expanded form. And this other one is 3 times n times m. Now, n times m and m times n, they're the same thing. So the order, because of multiplication, doesn't matter as long as there's the same pronumeral. There's an m and an m and an n and an n. That will make them, they are like terms. Having a look here on question F, we're looking for the pronumerals. There's a y and there's a y2. Immediately I can tell, and also there's no x in both of them, they are unlike terms. This 5 squared here, even though it's raised to the power, that's just saying 5 times 5, which is 25. So we can... So when we're looking for like terms, we must have the same pronumeral or letter, and we must have the same index, the power. So the key words here, think that's the letters or symbols, and this one is the powers. That's what we're looking for when we want to add or subtract like terms. Let's go down to example 3. Simplify each expression if possible. Now we can only add and subtract if they're like terms. I'm going to put a here, 4a plus 7a. Do I have the same pronumeral? Yes, they both have an a. They're both got the same index or power. And 4a's plus 7a's, I then have 11a's. B. Let's have a look. 3x squared y, so I've got x times x in there, plus 4x squared y, minus 2x squared y. If we're looking at, they all have an x. The index is also 2 for the x, which is perfect. This has a y, this one has a y, and that one has a y. Wonderful, that are all like terms. So we can add these all together. If I have 3 of them plus 4 of them, that gives me 7 minus 2. I'm left with 5x squared y. So 3x squared y's plus 4x squared y's made 7x squared y's minus 2x squared y's. All right, question C. 5m plus 6n. Do we have the same pronumeral? We don't, therefore that is as far as you can go. We cannot add and subtract them together. All right, might move over to the side of the page here to do D. Once again, I've got 9b plus 2 plus 2c minus 3b plus 6c. Let's look at our first term, 9b. That is also, there's a like term there, minus 3b. Here I have plus 2c and plus 6c. Notice I'm taking the sign with it at the front because that's telling us what to add and subtract. I can actually rewrite this with my like terms next to each other. 9b minus 3b plus 2c plus 6c. And we can now collect like terms, so we can add and subtract the ones that are alike. There we are there. To simplify it, and that will be as far as we go. 9b's, take away 3b's, 6b's, 2c's plus 6c's, I get plus 8c. And I've collected the like terms. All right, question E. 3z plus 5yx minus z minus 6x y. Let's go and see if we can collect some like terms. If you've got a highlighter when you're doing this, makes it easy. Sometimes circling, but I'll show you a circle method. If I have 3z minus 1z, they're like terms, that's just 1z. Here I have plus 5yx. Now this is minus 6xy. Now, as I said in those early examples, because it's times, as long as we have the same pronumeral and the same index, they are still like terms. So I have common ones there, and we can now look at collecting them. 3z minus z plus 5yx minus, and you could write the x and y in the other order if you preferred, but they are like terms. So I can now simplify. 3z's take away 1z, 2z. Here's a bit tricky. I have 5 yx's minus 6 of them. They are like. 5 minus 6 is actually minus 1 yx. Now, I didn't write it in, but 5 minus 6 is minus 1. If you're comfortable writing the minus 1 in there, if it makes you more comfortable, you're more than welcome. All right, I'm just going to move example 4 down a little bit. So I'm going to finish off our questions. So I'm going to do F, A, B, C, E. I'm going to do F with a bit more room. Keeps going down. Question F. I've got 6x cubed minus 4x squared plus 5x cubed. I'll use the circle method again. We do have all x's, but they have a different index, if you can notice. So the ones with the same index, same letter, same index, they are like terms. And the minus 4x, don't forget that it's got a minus with it, is an unlike term, this one here. I'm going to rewrite it. 6x cubed plus 5x cubed minus 4x squared. Adding these together, 6 and plus 5 is 11x cubes. They're like terms, so I can add and subtract, but I cannot add and subtract the final x squared here, and that's the final result. So just in those ones, make sure that you're being cautious of your negatives. Up here with the green and red one, notice that I circled the operation in front. Example 4. Example 4 has fractions. Now, the moment I see a fraction and add and subtract, I know that I need a common denominator. So I'll write this question A out here. And I have x over 2 plus x over 3. Now I cannot add and subtract until I have a common denominator. The denominator is the one on the bottom. They have to be the same to add and subtract. To make them the same, we look for a common multiple. Now, 2 and 3, I know that they go nicely into 6. So I'm actually looking to make sixths. Now, if I multiply the bottom by 3, I get 6, which means I do the same to the top. And x times 3 would make 3x. Over this side, I could multiply by 2, multiply by 2. That's where the 6 was built from. X times 2 is 2x. Common denominator, I can now add my numerators. So these two are like terms, meaning they can be added together. 2x's plus, or 3x's plus 2x's, I would get 5x and all over 6. So this one I had to build a common denominator before I could simplify, and checking that I had like terms the whole time. Let's have a look at question B. Very similar. We once again have to build a common denominator. 3x over 4 minus 2x over 5. A common multiple, so I've got 4 here and a 5. The first one I think about is that I might make them out of 20. We might need to simplify later, but if I build them up to 20, I can subtract them. All right, we'll multiply by 5 to get to 20, which means I have to multiply the numerator by 5. 3x times 5 is 15x. 5 times 4 is 20, times by 4 here. 2 times 4 is 8, and I've got x's. Wonderful that I've got common denominators here, so I can add and subtract, and I have like terms at the top. They're both only a single x. So 15 minus 8 would give 7x's over 20. And 7 and 20 can't simplify, so we can leave our answer there. A few pressure points in this. Making sure that you keep the right signs together. Obviously, negatives here, and on the Z, I kept the negative in front of it. That's a little pressure point there. Looking for the same, looking at F here, looking for the same pronumeral, but if there's a different index, they are unlike terms. Example 4, you may need to create a common denominator before you can simplify. Thank you.